So here is a question for number 33 of Project Euler. Digit cancelling fractions. Problem 33. The fraction 49 over 98 is a curious fraction. As an experienced mathematician, in attempting to simplify it may incorrectly believe that 49 over 98 is 4 over 8. Well, it's actually correct, but the cancellation has a problem. He has cancelled the 9s from 49 and 98. Only in this special case, that's a correct fraction. We shall consider a fraction like 30 over 50, which is equal to 3 over 5 to be a trivial example. There are exactly 4 non-trivial examples of this type of fractions that are less than 1 in value and containing 2 digits in the numerator and 2 in the denominator. If the product of these 4 fractions is given in the lowest common terms, find the value of the denominator. So imagine the number is a 2-digit number, right? So we call one of the digits n1 and the other one n0. For the denominator, we just do the same, d1 and d0 for for the first digit and the second digit of denominator. Then there are 2 cases. Whether n1 is equal to d0 or n0 is equal to d1 or none of them. Well, if one of these 2 conditions are correct, then we are able to simplify the fraction into a new fraction, which is n0 over d1 for the first case or n1 over d0 for the second case. And then we have to check if the new fraction is just the same as the first fraction or not. So in this case, if you should check if n0 over d1 is the same as n over d or not. Right. So if they are the same, because we are looking at integer numbers here, so we have to turn the fraction into a multiplication. So n times d1 should be the same as n0 times d. So if this is correct, that fraction is a correct simplification of the first fraction. And in the second case, we have n1 over d0 should be equal to n over d. So n times d1 should be the same as d times n1. Oh, I'm sorry. This is d0. So if both conditions are correct, so we can say that this is a correct simplification and this is all fine. And there is one other thing that you should take care of, that the n should be less than the d. The denominator should always be less than the denominator, because in the question it says that the fraction is less than 1. So which means that the denominators are less than the denominator. So first I define 2 variables, p1 and p2. p1 and p2 are the multiplication of the nominators and denominators for the correct cases, for the cases that we want to take care of. And then it says that the denominator and denominator are both 2-digit numbers. So they both have to be in the domain of 10 to 100. And n should be less than d. So first I create a loop for denominators. It starts from 10 to 100. And then for denominator, it starts from 10 to d. So as I said earlier, the numerator should be less than the denominator. So that should also be considered in the definition of the loop. And then I define n0 and n1, d0 and d1. These two are the digits of denominator and denominator. I find one of the digits by the remainder of the number over 10, which will give me the right-hand digit. The other one is by dividing the denominator over 10, which will give me the left-hand digit. I do the same thing for the denominator. So these two lines gives me the digits. We first check if in the first statement n1 is equal to d0 or not. If they are, we will check if the new fraction is just the same as the old fraction or not by doing this. And then if they are the same, I will multiply them and put them into the main part, in the P1 and P2. And for the second statement, which is the other way around, n0 is equal to d1, and then I will check if this is a correct fraction and it's equal to the old fraction or not. If they are, I will again multiply the new answer with the old ones. And then I just, and then because it asks for the simplest way, we have to use the GCD. GCD is the greatest common divisor. To find the GCD, I use this algorithm, which will find the GCD of two numbers A and B. And we use the GCD a lot of times and we'll use it again. So this is important to know. If B is 0, so which means that we have already found the GCD. If it's not, we will find the GCD of B and the remainder of A and B. So in this way, B gets smaller every time until we find the GCD. So the answer is 100. And if you check the question, the answer is 100, just the same as the one that we found there.